Hello to everyone. Thank you very much for this opportunity for presenting the paper and moving my paper from the other session because of traveling time today. My name is Fuad Hadžikadunić, and on behalf of my colleagues, the author of the paper, Nedeljko Vukojević, colleague Zlatan, Ištvanić, Mustafa, Hadžalić, and young colleague, PhD student Amna Bajtarević-Jeleč, I'm greeting you. And the paper under the title Assessment of the Structural Parameter Significance using the experiment design in the production of pressure vessels heads means that we are in the field of pressure vessels. And I'm sorry, I'm coming from University of Zenica. This investigation research is made under the large investigation PhD research of our colleague Zlatan Ištvanić for the needs of the company Metacom in Bosnia and Herzegovina. Oh, sorry. Okay, the production of pressure vessels means that we are taking the one part of that. It's the pressure vessel heads. And it's made in these circumstances as usual, but not in that way, as you can see later, by incremental sheet forming. And with this technology, it means that large significance or this combination of parameters can get to the constructional part of the construction to possible brittle fracture. In the experimental design that we used several input informations or parameters in the manner to research their influence on two parameters, fracture toughness and total impact energy. We measured 5 goal functions, residual stresses, those two ones, yield stress, and the hardness of the sequences, but those two goal functions will be presented here in the paper. We tried to manage and research how the post-weld heat treatment influenced on the construction, but it will be noticed that there is no influence of the thermal treatment in the manner that it is not necessary for the production. We will see at the end the influence of combination of analyzed input parameters on the total impact energy. It has a good agreement with the regression model, but in the case of the fracture toughness, it's not the same situation. We use the methodology of experimental design. It means that we use objective approach with experimental designing, with no efforts of the experimentator, and the subjective approach. We use all combinations of parameters with themselves and their interactions, cumulative interactions on the process. And the process will show us the regression model, the influence of each parameters and their intercollision significance, etc., etc. Some of parameters like dimensions, material grade can cause the different effects of, as also we know. And the goal of the experiment design is to obtain the interaction of individual observed factors such as 3 of them: yield stress of the base material, vessel head diameter, sheet thickness in the base core of the experimental design, and extra welding heat treatment on the observed 2 output sides that we mentioned, total impact energy and fracture toughness. We used the special approach for making the experimental materials. It is not the case in real production of these pressure vessel ends. We used 3 materials: 3 thicknesses, and 3 diameters. In total, we made 4 segment vessel heads and with 12 circular sections. You can see the process here. This is the usual approach of the making of the process. 2 main plates will be always used for the incremental deformation process with special press. But for these cases, for this case of research, we use this approach because of the spare of materials and for the process, because it will be needed much more material for use in the proper way as usual in industry. This is only used for the research investigation. We measure thicknesses and all parameters that we use in the process. We had 3 diameter, 3 type of materials, and 3 thicknesses, as I said. Those are the C equivalent table, welding procedure under the standards, etc., etc. It's not important to go in details. And the goal of this table of parameters and their levels relevant for the design of experiment, we used 3 parameters and the 1 extra because we use the matrix 2 with exponential 4 minus 1, not in basic 2 and 3, no, 4 minus 1. Because the goal of the this experimental analysis is to obtain mathematical statistical regression model that can describe the goal output function in the manner of the input parameters. And you can see we used 3 level, 0 level, 1 and 2 for the experimental designing process. This is the total matrix, global plan matrix. And you can see 2 blocks, before and after heat treatment, and the use all combinations of parameters. And with post-processing experimental analysis, it can be concluded from the analysis what parameters and how much it concerns to the process developed and researched. You can see the situation that I've explained. The thermal treatment is of normalizing annealing is performed by these circumstances and values. Standard procedures for the G integral and the KV parameter, and you can see the output results for the proceeding with experimental procedure. After that, we can put the form of the regression formula, and we can use some principle of logarithmization. And after that, we can use the parameters in regression model, and we're trying to manage this polynomial expression linearized. We presume that the combination of linearization with parameters on 1st degree, 2nd degree, and 3rd degree will be in the process. But with the research of these input informations, we will conclude the regression model at final. We use MATLAB module for that, and the first analysis showed that from the regression model, a very significant influence of the parameter T, thickness, and the less influence on the parameters yield stress and diameter is visible, while the parameter D, diameter, is insignificant in both cases for the observing the output value of total impact energy you can see the regression model. Some of parameters are included, some outcluded or not relevant. And you can see the expression. R-square information points that after analysis of press RMSE, RMSE R-square and press R-square indicate a satisfactory match between the real data and experiment for this kind of output function. As I said, some of the input parameters itself or its square is relevant, but some of them are not relevant and can be excluded from the situation. Some other surface response and contour plot diagrams also by seeing can show us the influence of some parameters or their interactions to the outgoing goal function. In this case, it is relevant that there is an influence of some of their parameters or their interactions to the process. Some of display of error variance, it's a special story about that, never mind for now. But this module in MATLAB also can help in that manner. For this parametric dependent function, it is showed that, as you can see at the first diagram, there are in dispersion model so much dispersion of results, and in real results and the predicted regression model that cannot be connected as we assumed. You can see that R-square parameter shows that, and it's not already relevant if there is influence of some parameters, but the regression model can't explain the process for this parameter. As you can see, all the diagrams. And in conclusions, using the experiment designs, we have practical significance, and it's very useful for this kind of experiment or any kind of scientific research experiments. According to the conducted statistical pattern, the diameters of the vessel heads can be excluded in further analysis as a parameter, as we said, and that has no significant influence on the size of total impact energy in the welded vessel head, while the influence of the thickness of the sheet metal and the quality of the material is very significant. Another important parameter is post-welding heat treatment. And it is there is space for another research, the manner of the influence of the heat treatment, but in these circumstances there is no influence, and for the K factor it is shown that there is no use for the and need for welding heat treatment. And it is said here, because of the economic point of view, it's not needed to use heat treatment without jeopardizing the strength of the vessel head. And at the end, among the 5 goal functions, residual stresses, it is showed, are the most important for the integrity of this kind of constructions. Thank you very much. If you have questions, I'm at your disposal.